So I mentioned that today we're going to be building on the blue ponds and the hands-on equations that we started with earlier this week. They did have some limitations, and we're going to try to fix some of those limitations by solving equations algebraically. Really, the main idea is isolating the variable. We want to find out how much that variable weighs, the value of that variable. And by getting it by itself, we can determine how much it weighs and what its value is. And to do that, we use what's called the inverse operation. It sounds fancy, it's not. Inverse just means opposite. You can think of an equation as being like a knot, right? So the x is all knotted up in this equation. And in order to undo the knot, you just do everything in reverse. Inverse, reverse operation. So let's connect the algebraic with our hands-on equations. All right, so here we've got an equation, 3 plus x equals 5. Most people can do this without solving algebraically, but I want to show you the steps on how to do this. So let's take our hands-on equations and do a 3, so our number cubed 3, and then we're adding to it our x, which is our pawn. Then on the other side we have a 5. In order to find out what the value of that pawn is, we have to do our legal move. Our legal move is to remove 3 from this side, and we have to do the same thing to the other side to keep it balanced. So we take away 3 from this side. It's the exact same thing here. I have a 3. I want to get the x by itself, so I'm going to take away 3. Whatever I do to this side, I also have to do to this side to keep it balanced. I have 3 and I take away 3, so now those are gone. That leaves my x alone on this side. And then I take my 5 minus 3, which gives me 2. So my x equals 2. This is solving it using our pawns. This is solving it algebraically. This is one of the areas that our blue pawns did not do very well. Here I've got x minus 4 equals 12. If I were to represent that on our pawns, we've got an x, and we've got a minus 4, which is a tile, and then we got a 12 on the other side. Now, because this is a minus 4 or a negative 4, the 12 is pushing down. It's a weight that's going down. The negative 4 is actually pulling up. You could think of it as maybe like a balloon. So the balloon is pulling our 4 up. And the strength of that balloon is, 4. In order to get this pawn by itself, I have to get rid of this negative 4. So to get rid of that negative 4, I add 4 to this side, and then I add 4 to this side. It brings this side level. Same over here. I have x, and I'm taking away 4. So to undo the takeaway 4, I add 4. In order to keep these, even, I add 4 to this side. Inverse operation, the opposite of subtraction, is addition. Cancel those. So x is now by itself, and on the other side, 12 plus 4, which is 16. So there's addition and subtraction. Multiplication and division are the same way. Two x equals 10. So if we did that with our pawns, we've got 2 x's, and on the other side we have a 10. And what this says is that this side is 10, and this whole side is 10. This 10 is being divided evenly by these 2 pawns. So because it's being divided evenly, we can divide both sides by the pawns. 2 pawns, if I divide 2 divided by 2 gives us 1x. So those cancel, leaving us our 1x. On the other side, 10 divided by 2 gives us 5. Division works the exact same way. X divided by 3. And I do the inverse operation. X divided by 3. In order to get rid of the divided by 3, I'm going to multiply both sides by 3. And multiply by 3. So I've got a fraction times a fraction. My 3 on the top and the bottom, I can cancel those. Leaves me with an x over 1, which is just x. That equals 4 times 3, which is 12. These are what are called one-step equations. They're called one-step equations because you're always one legal move away from the answer. So here you subtract 3, add 4, divide by 2, multiply by 3. So you're always one step from your answer. Yes, ma'am?
So you always do the opposite?
Yep.
On it?
Always. Yep, that's the inverse operation. So to get rid of addition, you subtract. Get rid of subtraction, you add. And everything is its opposite. They're not always going to be one step, though. Sometimes you'll have more than that. So here's an example of a two-step equation. Remember that you want to get the variable by itself. So you want to get these right here all by themselves first. So I have to get rid of this 10. How do I get rid of the 10? Tabitha? I can't multiply by... I have 3 x's over here, and then I have this number cubed 10. So how do I get rid of that 10? So you want to add 10 to this side? If I have 10 and I add 10, is it going to take that 10 away? Yeah, I want to subtract the 10. Exactly. And whatever I do on this side, I also have to do on this side. So now those cancel. That leaves me with 3x on this side. 1 minus 10 gives us negative 9. And now I've got 3x equals negative 9. Lacey?
Well, why couldn't you do the same thing for the 3x?
What do you mean?
You said you had to subtract the 10.
Mm-hmm.
Is there anything you could do with the 3x, like subtract 3x?
Well, we can't do it all at one time. We have to do this in multiple stages. It's just like when we had the blue pawns, like we had to make legal moves. So we subtract the 10s first, and then we can worry about the pawns themselves. So now we've got our 3x's. We got rid of the 10, so now we're closer to our answer. So how am I going to get these x's by themselves? Alexis?
Divide by 3.
Divided by 3. So that means our x is equal to negative 9 divided by 3 is a negative 3. The best part about problems like these, you get to use your calculator, which is nice. But if we think that the answer is negative 3, we can actually plug this in for x. So I'm going to do 3 times x. We think x is negative 3. So we do negative 3 plus 10 equals 1. So we know that our answer is right. All we did was we plugged that equation back in and found that our answer equals that. Number 6. $12 minus 7y equals negative 2. Based on what we've done so far, I want you to try and do that one on your own. All right, so we're trying to get the variable by itself. What's the first thing I could do, Mr. Wilder? Subtract 12 from the side. So I have a number cube 12, or I have 12. Take away 12. Perfect. Negative 2 minus 12 gives us a negative 20. And what's going to go on this side over here? Because I got this weird minus 7y. Brady? Oh, I'm sorry. Sorry. 14. You're right. So then what's going to happen to this minus 7y thing over here? Lacey?
Couldn't you add 7y to both?
You could add 7y to both, but I don't know that that would... You really want to get these by themselves so that you can find out how much they weigh. If I add 7y's to this side, then it just moves them over here. So then I'll have this plus 7y, and I'll have nothing over here. So that doesn't... I really want to get these by themselves. Taylor? Yeah, that's what we were just talking about. Lacey mentioned that we could add 7 to both sides. But the problem is if I add 7y's to this side, then I have to add 7y's to this side. Which means that these will cancel, which will leave nothing over here. And on this side, I'll have 7y's. That doesn't get us any closer to the answer. We really want to get these guys by themselves. So what I would do is I would think about it as subtraction, right? So subtracting a number is the same as adding its opposite, which makes this negative 7y. Now we can solve it exactly like we did up here. Divide by negative 7, divide by negative 7. So when I do that, negative divided by negative cancels out to be a 1y. Negative divided by negative is a positive. 14 divided by 7 is 2. Positive 2. $10 minus 5r plus 2 equals 32. Put a line down the equal sign. I do this, I put the line down there because it's easier to see kind of the different sides of the equation. And we're trying to get these r's by themselves. First thing I'm going to do, I don't like subtraction. I know you guys don't like subtraction either. Get rid of it. Yeah, subtracting by a number, same as adding its opposite, or same, change, and then change. So to get this by itself, I got to get rid of this 10 and the 2. So I'm going to subtract 12 from this side. Subtract 12 from this side. When I do that, it leaves me with my negative 5r. 32 minus 12. Well, that gives me 20. And now what? I got negative 5r equals 20. What am I going to do? Jeremiah?
You divide 20 by on each side.
You divide by 20 or you divide? Yeah, whatever I do to one side, I also have to do the other side, so it has to balance out. This is negative 5 times r, so I have to do the opposite. When I do that, negative 5 divided by negative 5 gives me 1r. 20 divided by negative 5 gives me a negative 4. Yes, ma'am.
You added the 10 and 2 together, but couldn't you done them separately?
You could have, yeah, I could have done a minus 10, and then done a minus 2, minus 2. Yes, I could have done them separately. Try that one on your own. All right. First step. Brittany, what did you do for your first step?
I did it, and I'm doing it.
All right. Well, we're trying to get these x's by themselves. So how can we get these x's by themselves? You want to subtract 2? All right, so remember when we talked about like the blue ponds, right? So this is 2 x's, so that's 2 blue ponds. So do you want to subtract 2 blue ponds, or do you want to subtract the number 2?
Wait, but you have to... You couldn't subtract the pond because there's no pond on the other side.
Correct.
Okay.
But there is numbers on both sides.
So could you subtract 8 from 15?
I think I want to get these by themselves, though. So I want to get this off of this side. How do I get this off of this side? I have 18. How could I get rid of the 18? Jaden, help her out.
Okay, so if you could like subtract the 18 from the negative 8.
Yeah, so negative 8 minus 18 gives you negative 26.
And then you could, since there's 2 left, then you get 26 divided by 2, negative 13, well, negative 13, right?
I'm looking at this right here. Would this be a positive 2 or a negative 2? Yeah, I think that would be a negative 2x. But everything you said is perfect. Yeah, I'm going to divide by negative 2 instead of a 2. And divide by a negative 2. Negative and the negative is a positive. 26 divided by 2 is 13 equals x. And that is perfect. Yes, sir, Mr. Tracy.
I did it a different way, but I got the same answer.
How'd you do it?
I took 18 and then
I took 2x and then kept multiplying 12, and eventually I got 24, but that was 22, so I added up to 26, and I got x equals 13 because 13 plus 15 is 26, and I eventually got 18 minus 26 and got negative 8.
Yeah. So what you did was you kind of used, sounds like more like a guess and check kind of method. Yeah. No, it'll work. It's a lot harder and it's more time consuming. All right, let's do one more. 2 parentheses x plus 3. All right. So we've looked at distributive property this week, but we did not look at distributive property when we were solving equations. Try that one on your own. All right, Jared, what did you get?
I got 2.
And how did you do that?
Well, I had to do 2 times x equals 2x, and I had to do 2 times 3, which equals 6. And then I did minus 6 on both sides, which equals just 2x and 10. I mean, 4. And then I had to divide that by 2, which equals 2x.
Hey, you're moving way faster than I am. Yeah, that was great. So he used distributive property. Then to get that by itself, subtract 6 from both sides. Those cancel, leaves you with the 2, 4. Anybody do it a different way? Jaden, how'd you do it?
Well, I just okay, so I knew that it equaled 10, and then asking what, times, what 2 times whatever equals 10, and then it's a 3, so I knew that 2 times 5 equals 10, and 3. I mean, we need 2, go to 3, make 5.
Yeah, no, that makes complete sense. 2 times 5 is 10, so this had to equal 5, so 3 plus 2 gives you 5. Yeah, it makes perfect sense. Miss Nicholas.
So I did the distributive property, and I got 2x equals 6, and then I minus 10 from that side, and then minus 10 from 6, and then I got negative 4, and then I got 2x plus negative 4, and then I minus 2, and then it'd be x equals 2.
Yeah, that works too. Sounds like a longer method, but yeah, absolutely. So there's a lot of different ways we could get that.